So this video describes how I changed the teaching of chemical problem solving in my classroom away from traditional lecture or traditional approaches. So in the way I learned chemistry and the way that chemistry is traditionally taught is there's a new problem type and the teacher goes to the board and says, here are the 5 steps for solving the problem. Any questions? Okay, so let me work an example problem, and the teacher works an example problem and looks at the students and says, any questions? And then the teacher says, go do a practice problem. Well, the research from chemical education on that approach says that all that approach does is tell students that the teacher knows how to solve chemical problems. It's not effective for helping students, especially not the best and the brightest, the run-of-the-mill students. It's not effective for helping them learn how to solve chemical problems. And so how do students learn to solve chemistry problems? And this would be true for physics as well, and I think for math, although I'm not a math teacher. They learn to solve mathematical problems by solving mathematical problems. So here's a brief overview of what I did. My chemistry textbook, so you would have a couple of pages on the new problem type, and excuse me, at the first thing that would happen is there would be a text section that described the new problem type. Then there would be a couple of example problems, and then there would be a practice problem section. So I begin with my students by breaking those apart, and in their groups they would have to read and discuss each section. So the first text-based section, I would give them just a couple of minutes to read individually, talk about it, and then to try and determine what is this new type of problem, chemistry problem that they're going to have to learn how to do, and how does it differ from what they've done before, or build on what they've done before. After they had read individually and talked, I would stop the class and say, any questions? And then probably question people on what's this new problem type, how's it differ? And they knew that I could ask anybody in the room, so the discussion before had to prepare everybody to answer what's this new problem type. Then I would say to them, now in your groups, read the 2 example problems and discuss them. So they would do that, discuss them, and then I would say, any questions? I usually wouldn't question them on that unless it's slightly like, okay, so how does this happen? Or what's different about these type of problems from others? Or how is it similar? Just to make sure that they're processing. Then the last thing I would do would be to give them a practice problem with the answer up on the board. So show them the practice problem and then the answer. And then I would say, now in your group, take one sheet of paper and work it together. That one sheet was to make them all come together with their heads on the problem, rather than, often if you give a group of 4 people and say, work this problem, people tend to almost just turn away from the group and do their own stuff. By, say, one sheet, the note taker would be writing what the group was coming up with. It forced them to come together. Then, after that was done, I would, they had the answer to see if they had the correct answer. I'm moving around. If a group's stuck, they can call me over. At the end of that, I pull them together and say, what questions do you have? What problems did you run into? Everybody know how to do this now? Answer any questions or concerns they have. Then, if we had enough class time, give them a couple of practice problems to work right there individually with group support. And all of this was tied together with bonus points. They knew on the next quiz or test, if everybody in the group hit a level of excellence like 85%, as an average on the quiz or the test, then everybody in the group got a bonus like 5% bonus points on the test. So if somebody made an 83 and they got the group average, then that person got an 88. One last thing. Breaking it apart, read the text, talk about it, read the example problem, talk about it, work a practice problem together, talk about it. That breaking that apart was a scaffold to get them used to the method. My students got to the point where I could say to them, um, I could say, here's our new section. Now, with your group, read about the new problem, look at the examples, the practice problems on the board, there's the answer, work that together, and if you get stuck, call me over. And in 15 minutes, 10, 15, 20 minutes, depending on how complex the problem was, they had worked it through and they knew the new problem type. Remember, they would always have time to ask me questions. At the end of that 15 minutes or so, I'd pull them all together as a group and then pepper with questions. Same thing. What's this new problem type? How do you do it? How's it different? I would never leave them alone, but it wasn't me at the front of the classroom modeling problems. The biggest shift was they were solving problems with the help of a peer. And what I saw was my understanding of chemical problem solving went from only the top 20% to the top 80%. It was astounding. Almost all of my students could solve chemical problem solving, and I think it's because they were learning to solve chemistry problems by doing it with their peers. Hope that helps.